And of course, I'm on mute. Hi, everyone. It's 4:01 here in Berlin. It was 4 when I started. So there's that. My name is Juraci Paixão Crowley. I'm a software engineer, and every other Friday, I bring it to you here on Telemetry Drops. News about OpenTelemetry, but also observability, monitoring, and everything in between. I try to focus on OpenTelemetry, so that's my niche, that's what I know. And from time to time, I bring here some guests also to talk about specific things on OpenTelemetry, things they are passionate about. We talked about the Java performance with Jason and Bruno. We talked about OB last week. We talked about so many things. We talked about blueprints. We talked about you go back in the episodes and you know everything that we talked about. Today, we're going to talk about the OpenTelemetry Injector with Michele. But before I call Michele in, I have a few things to mention. So the first one is, I'm working on a side project of this side project, and this is called the OpenTelemetry Drops. It is an experiment that I'm running, and it's a podcast that is mostly AI generated. But I hear that I listen to the episodes before they go live, and I actually enjoy them. I built it for myself. So my problem was I'm so busy with all the things that I have to do at Oli Garden. So the hat that I wear most of the week, that I was falling behind on OpenTelemetry, and I thought that it would be nice to have a podcast that would give me the updates from the community, from inside the community. So what is happening in terms of pull requests? What is happening in terms of the discussions during the SIG calls? What is happening in terms of the specification changes and proposals and things like that? And this is why I built this podcast. I started a few weeks ago. I ran a few, I have a couple of episodes that didn't go public. I use it for myself. I enjoyed. I shared with a few people. They liked, and now it's public. So go to telemetrydrops.com, and there is a link to OpenTelemetry Drops there. If you want, you can go straight to Spotify and type in OpenTelemetry Drops, and you can find the podcast there. We have 3 episodes, and one is going live tomorrow evening, Berlin time. So the next one is tomorrow. It's already recorded. It's already prepared, and I'm listening to that today. The show is, again, mostly AI, 3 voices, 3 different characters, and 3 different experiences, backgrounds. I hope you enjoy. It is fun. I'm having fun with that, both producing and listening as well. Besides OpenTelemetry Drops, we have a new OTCA quiz on telemetrydrops.com. So if you are planning on doing OTCA, the OpenTelemetry Certified Associate, go to telemetrydrops.com. At the top, you're going to see the OTCA preparation exam. I heard that it's harder than the actual exam. So if you can pass it 3 times, I can almost guarantee that you can pass the OTCA. So go there, run the tests, run the exam, and get me your feedback. Tell me what's going on. Is it good? Is it bad? Is it ambiguous? It is not ambiguous. A few people shared some feedback already. I sorted them out. I saw some questions that were they seemed tricky. I removed them, but the questionnaire is there. The exam is there. So try it out. And finally, next week I'm in Brazil. I'm in São Paulo. Next week on Wednesday, we have an event with Grafana. On Thursday, we have an event with Elastic. And on Friday, we have an open event, free for all, where we are going to reproduce Hotel Night. So every couple of months, we have Hotel Night here in Berlin. The next one is in April. And this time, I want to do an hotel afternoon in São Paulo, a whole afternoon where we talk about OpenTelemetry with people who are actually doing OpenTelemetry on a daily basis. So we have a presentation from people from Mercado Libre. We're going to have a presentation from people from Bradesco, and one presentation from me as well. So if you are in São Paulo, if you are in the area, you can't miss it. So go to the Cloud Natives São Paulo, that's the chapter, and in there you're going to find the link to the next event, Tarde de OpenTelemetry in Portuguese. You can't miss it. And with all of that, we have KubeCon. We have a lot of other events as well, but we have time to talk about them eventually in future episodes, because now I want to call in Michele, and I talked already a lot. But let me call Michele in. There you go. Hey, Michele, how are you doing, man?
Fine. I was still fussing with my setup. It will happen until effectively the end of the episode, just to be clear.
So for those who don't know, who are you, Michele?
Oh, I'm an observability nerd. I have been on the giving and receiving end of observability for almost my entire career. I am a founding member of Zero and a maintainer of the OpenTelemetry Injector in the OpenTelemetry project.
Okay, and that's our main topic today. So I don't know what is the OTel injector. So what is OpenTelemetry Injector?
Oh, all right. So OpenTelemetry has a lot of capabilities. You can create logs, you can create spans, you can create metrics. And it usually takes a little bit more work than anybody would like. You need to go and add the SDK to your applications. You need to go and configure auto instrumentations. The way that you do it changes remarkably depending on whether you're running on a container on Docker desktop or you're running on a virtual machine on a Kubernetes cluster. And usually when I talk to people that are adopting OpenTelemetry and they ask me, hey, how do I add OpenTelemetry to my applications? The answer is yes, that there is 50 different ways. And so, of course, I would think of making yet another one, but this in a very automated fashion. I like my observability to be really easy to set up. Ideally, I would have a magic wand and point it at things and say, hey, OpenTelemetry, get me telemetry from that. And the OpenTelemetry Injector is something that gets really, really close to it.
So can you tell me a little bit about, so that sounds promising. That sounds like magic wands. I think I like it. But what is it actually for on technical terms? Like what is the injector and what is the thing that I'm trying to install here?
All right. So the way that you add OpenTelemetry to applications changes from effectively programming language and runtime to runtime. The way you add the OpenTelemetry Java agent to your Java applications is different than the way you add the .NET SDK and instrumentations, and different from Python, JS, and so on and so forth. What the OpenTelemetry Injector does is to give you a very uniform way of doing this using the LD preload hook, so that you just say you add the injector to your application, and you don't really add it to your application, more to the environment around the application, really. And then the injector does the rest. Sometimes people come to me and say, hey, but what's the difference between the injector and Grafana Bela? And it is a remarkable difference. What the injector does is effectively activate OpenTelemetry instrumentation coming from the language-specific SDKs. Bela kind of, in some sense, does a different implementation of ABPF, although it can also inject the instrumentations. So there are different approaches with different pros and cons.
Got it. Are we talking about here the applications that I write myself, or are we talking about here the things that I manage, like my Kubernetes? Do I use the injector to get my Kubernetes metrics or my MySQL metrics, or is it for my applications?
So it is for anything that is written in Java, Python, Node.js, .NET, and later on we'll probably add Ruby support, maybe Elixir is somebody from that SIG comes to have fun with us. It's more a matter of the language it is written in, more than whether you manage it or you write it or somebody else did. At the end of the day, the OpenTelemetry SDK does not care if that Java application, something you wrote or something that you're paying somebody to give you the binaries. But for example, the injector cannot inject things like Rust, Go, C, C++, because there are no auto instrumentations that can be activated through process environment manipulation. So we will get there.
Yes. So going back just a little bit. So I use then the injector to add things that exist outside of the injector. So it exists already in OpenTelemetry community, like the Java auto instrumentation and libraries and so on. So I use the injector to hook into the initialization of my application, and then it inquires what is the application that is running. Is it Java? And it is Java. Then it injects the auto instrumentation from Java there. So the injector does not do instrumentation on its own, right?
It really does inject the Java instrumentations, but it does not really look up whether it's Java.net or whatever. It doesn't need to discover it. It's there is a lot to unpack. So effectively, the fundamental idea is for a bunch of programming languages, Java, Python, Node.js, .NET, Ruby, and so on and so forth. You can activate an OpenTelemetry SDK and the associated auto instrumentations as long as the files of the auto SDK and the instrumentations are in the file system somewhere where the application can see them, and you can manipulate at the right time the process environment of your application. Process environment is what happens when you set environment variables, or what you look up with the env command, or what you set in Kubernetes to pass secrets and stuff. So it's effectively key value pairs managed by Linux for you and passed, in a sense, to the startup of the application. Most of the times, the way that people add, for example, the OpenTelemetry Java agent is by putting the jar file somewhere and then set the either the minus Java agent system property, or by setting the system property using the Java tool options environment variable, which is a way to pass additional startup parameters to your JVM. So if you have the jar file somewhere and you can modify the process environment, you can start effectively the OpenTelemetry Java agent on startup in Java applications. And the same can be done in a bunch of other languages. For example, in Node.js, you can use the node_options environment variable to pass either --acquire or --import, depending on the version of Node.js that you want to use. .NET, you need to set like 6 or 7 environment variables. Python is a very interesting thing involving the Python path and site customize. Maybe we'll get there, maybe not. But ultimately, what you need to remember from this is you have the right files in the right place, visible to the application, and you can modify the process environment. If you can do that, you can add OpenTelemetry to your applications without, like at runtime, without changing them at deployment time.
Got it. So I want to go forward at like 2 steps. I know 2 questions that I want to ask deriving from that, what I just said. But going back 1 step, just to make it clear, who's the audience there? So not me as a software developer. So not me. So this is not for me that I'm looking to instrument my applications manually. This is more like the operator that has to run some code and doesn't have the knowledge or the will to do the manual instrumentation there. So they get the injector to do the auto instrumentation of those applications. Is that fair?
It is very fair, but we should also mention sometimes the operators have both the will and the knowledge, but lack the opportunity.
That's true.
There are situations, for example, where you are required to deploy the images that the developers push, and they have verified tags, and you do not get to add more to that image. You need to take it the way it is. So even if you wanted, you couldn't add the data, not without a whole bunch of interactions that I will actually show in a demo about how it works in Kubernetes.
Yes. Do you want to show the demo right now? I can get it.
Yes, let's pivot to that. I added a stream. Oh, excellent.
Oops.
Well, I stopped for the blink of an eye.
Oh, I'm sorry. Yeah, so you saw it here, perhaps. There you go. Yes.
So I'm going to show you the simplest demo application that you can imagine. I did it in Spring. If somebody in the audience is going to ask, hey, but Spring has Micrometer, yes, come talk to me. I have stories.
You should not have said that. People from the Micrometer community are going to come after you.
I welcome them. Come talk. There are things that we can improve together. This is a very simple REST application. It has effectively just a couple of endpoints. Yeah. Notice nowhere here there is any OpenTelemetry. Yeah. There is no packages, no importing. I could show you the Maven file. It is the most boring that you've ever seen. Boring in Maven is still a million lines, but still, it's boring. You would say, yeah, Michele, but you're cheating. Maybe you're putting it in the Docker file. No, this is the Docker file. If I had somewhere my OpenTelemetry agent, this is the place where, for example, I could add the binary Java agent, yeah, which I'm not doing. And my deployment files are equally simple. So I just go and have just the application deployed, just one container called demo app. So as boring as you can. In reality, I actually had Claude generate this probably half an hour before when I started talking. So it's like it's vanilla. It's like simpler you don't get. And if you deploy this application on Kubernetes, it will work, but it will not send any OpenTelemetry data. It has nothing of OTel inside. So instead, what I did, I added the -0 operator. It is a Kubernetes operator that uses the injector. The current OpenTelemetry Injector actually started as proprietary technology in -0, which we open sourced, joining people like Antoine, who were trying to get to the injector side from a different direction. And it's not yet part of the OpenTelemetry operator, otherwise I will be using that to demo, but hopefully this year it happens. Now, let's go and have a look at the actual application that is running. So I run my deployment script. My deployment script is equally boring as all the rest. I installed the -0 operator, and then I deployed my manifests for the application, and that's all I did. Now, let's go and look at the actual way that the application looks like. This is a significant amount of things more than what my deployment manifests did. And let's start from the very interesting bits. There is now an init container. Init containers in Kubernetes are containers that run before the rest. So effectively, you have two layers of containers. There are the init containers that are supposed to initialize stuff. And since a few versions of Kubernetes, they can also run in parallel with non-init containers with the sidecar model, which I never fully understood because the configurations are weird. This init container is, its job is actually to copy in a volume called the instrumentation volume, the files of the OpenTelemetry SDKs and the injector. So your pod comes up, there is a volume, it's an empty dir volume. Let me see if I find it. There we go. This is effectively, depending on how you run Kubernetes, either it's something in memory or it is something on the file system of the node, but it acts as a folder that you can share across containers in your pod. And the init container starts and copies the injector files and all the OpenTelemetry SDKs that are supported into this shared memory. There are actually modifications taking place also in the containers of my application. A whole bunch of environment variables to have better metadata in terms of resource attributes, but the important one is LD preload. This thing is the one that actually triggers the OpenTelemetry Injector inside your applications. And we're going to go into excruciating detail of how that works. But at the end of the story, by virtue of this variable and the injector and the other files that exist in the empty dir volume, you get the application running with absolutely no work whatsoever. In the -0 operator, all these modifications are done through an admission controller mutating webhook, which effectively sees Kubernetes cluster scheduling a pod, and it goes and says, wait a second, I need to add the injector to it. And then there is a bunch of modifications that occurs to the pod spec template that makes it happen.
That's very much like the OpenTelemetry operator with Java as well, right? So the OpenTelemetry operator does almost the same, like as an init. The mutating webhook takes a look at the pods. If the pod spec has a special notation, then it does environment variable injection, and then does the copying of the Java agent to the volume there and so on. Why would I then use the injector instead of the operator with the Java auto injector?
A number of reasons, actually. So the OpenTelemetry operator, you need to tell it pod by pod what you want to have injected. So I don't remember if it's labels or annotations, but you need to add something to a metadata of the pod to effectively have the operator add an instrumentation image, which doesn't contain the injector, but does contain the SDKs. And then instead of setting LD preload, if you tell it to inject Java, it will do Java tool options. But so first of all, like you need to know pod by pod what you want in there. And generally, you are not going to know on a large enough cluster. But we have been talking so far about the happy case, Java. Java is really simple. You have the Java agent jar, you're good to go. There are languages like .NET, like Python, where the specific binaries that you need to add to the application actually depend on how you built the application in the first place. Pretty much every runtime that people use out there to run applications, think of the Java virtual machine, think of the V8 Node runtime, C Python, C Ruby, the .NET environment, they are all linking to libc. libc is effectively the standard library of C. It has a lot of facilities, including the possibility to effectively the environment and how to manipulate it. We'll get there. Now, why do I mention libc? Because there is not one libc. There are two that are used very prominently in container environment. One is the GNU libc that we all know and love, and then there is Muscle, used in Alpine containers, which has been the bane of my existence, and has led, for example, to the injector being written in Zig. Now, before we get there, we need to inject the correct binary, for example, for Python, and the one for GNU libc is different than the one for Muscle libc. Same for .NET. What the OpenTelemetry operator asks you to do is, in case that you're not using the default, which is GNU libc, to actually state that it should use Muscle. That is an additional burden that you have to know, because if you're not sure if it's Python, you're probably going to have even less of an idea which base image it uses. The flavor of libc, it's something that tends, like 99% of the cases, it depends on your base image. Like one of the reasons to use a distro is, even in Linux, is to have this kind of shared utilities like libc, OpenSSL, and so on. So whether if you're using something like based on RHEL or Debian, it is going to be GNU libc. If you're using Alpine, it's going to be Muscle. Those are the rules of thumb. Yeah. If you went and added an injector built assuming libc, and you try to inject something that assumes Muscle, it explodes. The converse is also true. Specifically, your injector must not depend on libc itself. It must be entirely self-contained. And that is the reason why we didn't use Go and we didn't use Rust, which we would have loved to, is because Go, to be able to expose symbols, like ELF symbols, you need to have cgo, and cgo brings in a libc, and if it brings in a libc, you're screwed. And Rust, the standard library of Rust, depends on libc itself. There is, to this day, to the best of my knowledge, no Rust target, so way to build a Rust binary that is entirely self-contained and written in Rust. But Zig, the standard library of Zig, does not depend on libc. It builds directly on Linux, on the Linux headers and the kernel API, and that is amazing. And that's why we use Zig.
So I mean, just a reason to use another language would be enough for me to experiment with that as an engineer. But I think the whole idea, like the reasoning, is very sound. Like it does make sense. Is that the first case of Zig that you can imagine for that specific use case?
The OpenTelemetry Injector is, to my knowledge, the most advanced libc LD preload based injector used in observability. There is prior art. I built stuff like that at Lumigo. I built stuff like that at Instana. Those were both naked C, so it was just C without libc, which means that you have a really hard time doing, for example, input-output to validate that the files exist or to print out debug logs. Dynatrace has been using LD preload since the beginning of time, like 2016 with Rockset. But theirs, to the best of my knowledge, is also written in C. And it uses a pretty different philosophy than what we ended up doing in the OpenTelemetry Injector. I have not seen other examples that use Zig for this specific use case, and it was very cool to be the first project in OpenTelemetry to actually use Zig. Although now there is, I think Francesco in Italy is trying to set up a Zig SIG, special interest group, to actually, there is an OpenTelemetry Zig SDK, but to make it official.
Nice, Zig, nice. So he kind of had a similar question to what I had, but I think it is, so I got that the operator can now use the injector, but didn't do something very similar already without the injector. And I think it has information that I don't have yet. Is the operator using the injector already, or
not the OpenTelemetry operator? That's why I'm using the -0 operator, which
okay,
very similar things as the OpenTelemetry operator, but with much fewer knobs to turn.
Okay, so the idea is then that this kind of feature fits back into the OpenTelemetry operator at some time?
Yes, but it's not only the OpenTelemetry operator the target. Something else we're trying to do is to start a packaging special interest group in OpenTelemetry. Because in Kubernetes, for example, when you look at the OpenTelemetry operator or the OBI, so the OpenTelemetry eBPF instrumentation, you have ways to do automatic instrumentation. The OpenTelemetry operator requires you to go and put annotations and labels on your pods, and it's too much effort for me. I like it simple. eBPF is very cool, but requires it to run something with high security privileges, so that doesn't work, for example, on managed platforms like some flavors of GK Autopilot, EKS, and so on. So you can use eBPF if you effectively own the Linux kernel. Mm-hmm. But there are places that do not have Kubernetes. There are people out there that love to still run software directly on virtual machines. And by the way, I like the simplest thing that works. And this is not
that's me as well. I'm just joking. That's me as well. I like my machines. Yeah.
So for them, installing OpenTelemetry is every bit as hard as it has always been. Plus, they need to go and wrestle systemd to put environment variables and droplets and stuff. In the OpenTelemetry Injector project, we have a first version of system packages, deb and RPM for Debian derivatives and RPMs, rel derivatives, that effectively do the kind of things that I'm showing you, but to all the processes running on your Linux VM. And for them, there is no comparable automation outside of Bela.
Yeah. So I have a few questions, but Jovan also had a question here. So can we control what gets loaded by the injector based on the programming language used, or even make the injector detect the programming language and load the needed libraries for a specific language?
No, we have, in the OpenTelemetry Injector, we have admission and deny lists. So you can restrict which binaries will be injected based on where they are on the file system. And, for example, exclude entire directories if you want. That is based on configuration. We have not implemented the detection of the programming language because it's very much a moving target. So for things like the JVM, there is a couple of libraries like libgene, if I remember correctly, that virtually every JVM has and uses. .NET, there is some good rule of thumbs. When you go into Node.js, Python, then effectively you're going to play a whack-a-mole of all the possible ways that people are building those runtimes. So instead of doing that and having effectively false positives where we wouldn't be able to notice that it's actually Python, what the injector does today is that all the languages, all the processes it injects, it sets the environment variables for all the supported languages. It's something that you're going to notice only when you go and iterate inside your program about the environment, and all of a sudden you have in your Java process something that says node_options, but those are entirely benign. But it has never happened in the history of mankind that somebody wanted to use productively node_options inside the JVM process.
Got it. So there's one question from Ricardo that is not showing up here in the platform, but it is on LinkedIn. So I'm going to read that out loud. Can I understand the hotel injector as being typically used on VM bare metal while hotel operator is used in Kubernetes? And if not, when should each be used? I think you kind of, I think I kind of know the answer already, but let's be perhaps more explicit there.
So the injector is something that please use it in your VMs or your bare metal hosts, and the injector will make its way into the OpenTelemetry operator as well, because it actually improves upon the current experience in two ways. One, it will allow you not to have to go and annotate pod by pod what you want in there. It will just effectively kind of discover it for you. And the second aspect is that there are some things you can do in the entry point of your container, like overriding Java tool options, that could actually prevent the instrumentation injected by the OpenTelemetry operator from working. Because what the OpenTelemetry operator does, it does something similar to what you see on screen. It will go and add Java_tool_options as an environment in the container, but your entry point, that is the process that the container will start, the one that has PID1 inside the container C group, could actually override that. Very often, what you do is not directly start the JVM or Node.js inside the container, but you're going to have a bash script or a shell script that is going to do some interesting things. Some of those interesting things could actually prevent the instrumentation from activating, because it could override wholesale what you pass through Java tool options or node_options. But as long as LD preload is there, the injector will actually do the right thing from inside the process, as opposed as from the outside, the way the OpenTelemetry operator does.
I guess we go there now into an area that I didn't want to go in, but we are there. What happens when things fail? Like LD preload is not new, as you mentioned. Like Telemetry has been doing that for, I don't know, 2 decades now. Mm-hmm. I'm sure you've heard horror stories about LD preload before. I certainly did.
Awesome.
So, I mean, why on earth would I allow anything to do LD preload with my application? Like, what are the guarantees that I have that the injector is not going to break my application?
So there are two types of considerations to have. One that sometimes here is security. Like, oh, LD preload is unsafe. In terms of the security threat modeling, if somebody can put stuff inside your container, yeah, it's gone. So putting there the LD preload and doing injection by the LD preload is actually as safe in terms of security posture as just putting the OpenTelemetry SDKs yourself in there effectively. And something that is interesting to point out is that people let automatic instrumentations do a lot of interesting things to the logic of their applications without a second thought. And then they see LD preload and they go like, it's the end of the world. So it doesn't actually modify in any meaningful way the security posture. In terms of safety, there is a lot of knowledge that has gone into the current iteration of the injector, and there is a document inside the repository. Josie actually sent you a link to that in the notes. Maybe you can put it on screen. We went actually through several approaches. Like the easiest thing that we did in the beginning was, cool, we add through the injector, we expose a getenv dynamic symbol, and that is going to hijack the way that your application runtime looks up the process. And that worked sometimes, but not reliably, because while the JVM, Node.js, Python, blah, blah, they use the getenv function of libc to look up things like Java_tool_options. At runtime, when your application is running, it doesn't, when you do system.environment or system.env, I don't remember how it is in Java, or process.env in Node, it's not every time invoking the getenv function. It has actually parsed the memory location pointed at by the environ symbol. So you no longer get to actually modify the environment if you just do getenv. Then we tried another thing, and we said, okay, cool. We are going to expose getenv, but require the environment symbol, so that we're both. And it turns out that there are processes out there, like the AWS CNI binary, that are dynamically linked, so they will get injected, but that do not link libc. So in that case, the linker would fail. So we ended up doing something that is deliciously complex, but it works incredibly reliably. Like, we have not crashed anybody yet because of the injector. And we have been using it in production at Zero since almost 2 years. What we're doing is effectively the injector is added to your application. And it executes, it has an init array function. So there is a special symbol in ELF where you can link stuff that starts at runtime. And this logic at runtime goes and looks up information about the process itself. It goes and reads the ELF tables of the symbols to figure out which libc is actually bound. There is a symbol called DT_needed in the dynamic symbol table that will effectively list which libraries to link at runtime, and that's what the linker does. When you make /foobar, that foobar binary is seldom self-contained. If it's self-contained, it's called statically compiled. That is, the only dependencies it has is the Linux kernel, more or less. For 99% of the stuff that everybody runs, that binary has dynamic library dependencies like libc, like OpenSSL, and those are resolved at the start time of the process by the linker. What you do, for example, with the LD command. Yeah. So the injector goes, looks up at the linked, the needed libraries, and goes and looks for something called libc.so.6, which is the GNU libc in everything that is Debian derivative or RHEL, or looks for something like maso in the name, or LD_maso, and that we know it's Alpine. So cool. At this point, we know which library, which libc is linked. Then we go and look in memory where it is. There is something in Linux called memory maps. And you can look them up. And when your application loads a dynamic library, it effectively allocates a bunch of memory, copies the library into it, and allocates some more space for some environments and things, some variables and stuff, a bit more memory. The injector goes and looks up where in memory the libc is mapped, and then reads the ELF metadata from the memory of the process, no allocations, it's really efficient, where the LD_sim function is located. DLSim is a function that allows you to look up other symbols. When you go and look at how dynamic linking works and ELF, there's infinite amounts of fun. And we didn't want any of that because that would be dangerous. So instead, we did the list of work to look up the DLSim, which then knows how to do all the rest. So the injector has stage 0, figure out what libc it is. Stage 1, figure out where in memory the libc is. Stage 2, find the DLSim symbol. Stage 3, find where in memory are the environ symbol and the setem symbol. And based on that, we do all the rest. And this thing is really safe. If we cannot figure out which libc it is, the injector does nothing. It stops, but doesn't modify anything. If it doesn't find the DLSIM, stops, doesn't do anything. It barely even allocates any memory in the process. If we do not find environ or setenv, no modifications are happening to our application, nothing at all happens. If we get all the way, then the environment variables needed to activate the OpenTelemetry SDKs are set, and you're good to go.
So all of this then is so that you can set an environment variable?
Yeah, it's great. No, you can set it. Effectively, all of this is so that you can set LD preload environment variable generically, and we do all the rest for you, including picking which versions of the binaries to load, for example, for Python and .NET. Remember that those, you need to know if it's muscle C or libc.
No, I mean, I think it is a very useful tool for operators that don't have much control, and they have a lot of heterogeneous things running on their environment. So I have a lot of languages, I have a lot of versions of the things that I'm running. I don't care about those. Like I just want some telemetry coming out of my application. So that's when I would use that. So what are the downsides? Like when would I not use the injector to do the auto instrumentation for me, or to activate is that the right term? Like what do we say that injector does? It injects auto instrumentation? Yeah, okay.
Yes.
So when would I not want the injector to inject auto instrumentation for me?
So for example, if you have already added OpenTelemetry to your application by importing the packages. So for example, in Maven, I could have added the Auto SDK and the auto instrumentation instead of using the Auto Java agent to do it manually. In that case, we have some automations in the distros and some of the injection logic in the tertiary operator to avoid starting a second OpenTelemetry SDK. In some languages, it's fine. You may end up with double telemetry like Node. In some like .NET, .NET is not happy with that. In Python, also, we do a bunch of safeguards using a site customized script so that we do not inject twice. And if we see that the dependencies of Python application already have OpenTelemetry stuff inside, then we remove the additional dependencies from the load path, that's Python path, so it's safe. You may not want to add to inject applications if you do not care about those applications. So, for example, if like there are applications that you do not care to monitor, then you just exclude them, right? Then you don't care. Something that you can also do, which is I kind of prefer, to be honest, is you inject also the applications you don't care about, but the OpenTelemetry collector nearby will throw the data away from you. Why do I like this better? Because telling the OpenTelemetry collector not to throw data away is easier in production than adding injection or SDKs to stuff that don't have it yet. So it's a kind of better safe than sorry. And sure, it creates entropy and consumes electricity, and there is a little bit of overhead because of OpenTelemetry in your applications. But it saves you precious minutes during outages if you want to have more insights about those applications themselves.
And again, we are talking about applications that I typically run myself. I mean, I could probably extrapolate what you said and say, okay, so let me monitor all the processes that I have on my Linux server here. And that would be probably a bad idea, right?
No, in reality, no. When you go and look at, for example, what happens on a Linux server, most of the stuff that the injector will inject is actually things you put there yourself. There is relatively little, for example, out of the box in a Debian or a RHEL system coming with the distribution itself that will be injected. And those are easy to just drop.
Got it. Okay. Michele, I have so many other questions, but how can people find you and where can people ask you questions?
Oh, well, I'm in the CNCF Slack. We have the OTel Injector channel. Come and hang out. On GitHub, come and contribute. Come and find me at KubeCon EU in Amsterdam, where we two are going to have an additional adventure. But
Are we?
yeah, it's going to be keep an eye out for people taking unnecessary risks. Entertainment.
So just to be clear, I regret that already. All right. So
It's going to be very regrettable, but we're not going to say what it is. You need to keep an eye out on LinkedIn to know exactly what type of jeopardy we are going to put ourselves into.
Nice, cool. Michele, it's a pleasure talking to you, and thank you very, very much for coming to Telemetry Drops and talking about OpenTelemetry Injector. Thank you very much, and see you in Amsterdam, Michele. And to all of, let me close your screen here. So hide this one. There you go. And Michele, thank you very much.
Having me, folks. See you around. Bye.
And with that, thank you all very much for watching. If you enjoy Telemetry Drops, then click the thumbs up button, click the like button, help this content spread throughout your network as well, to the people that have the same OpenTelemetry thirst than you have. All right. So and on Sunday, a new episode of OpenTelemetry Drops is dropping on Spotify. With that said, we'll see you all in a few weeks' time. So we're not going to have our Telemetry Drops next week. I'm in São Paulo next week for an in-person event on Friday, March 6th at Bradesco in Alphaville. For those of you in São Paulo, I see you there in person. For all of you that are not going to be there, see you in a few weeks' time. Bye-bye.